Alright, so I'm going to need to find the derivative of negative 4x squared plus 4 using the definition of derivative. So I would start this, I would do limit as a limit of delta x approaches 0, and that would be negative 4, and then parentheses x plus delta x squared plus 4 minus parentheses negative 4x squared plus 4, and then that's all over delta x. Then I would simplify this to x plus delta x, and so I get limit as a limit of delta x approaches 0. It would be negative 4 parentheses x squared plus 2x delta x plus delta x squared plus 4x squared minus 4 all over delta x. Now I'm going to put the plug in the 4 for all the thing in the parentheses. So as a limit of delta x approaches 0, I get negative 4x squared minus 8x delta x minus 4 delta x squared plus 4 plus 4x squared plus or minus 4 over delta x. Now I'm going to simplify everything, so the negative 4x squared and the positive 4x squared and the positive 4 and the negative 4 all cancel. So it'll be negative 8x delta x minus 4 delta x squared all over delta x. Now I'm going to take out a delta x, it'll be delta x parentheses 8 negative 8x minus 4 delta x. And now since the delta x equals 0, that cancels. So the answer will be negative 8x. Now I'm going to find the derivative of 3x to the fifth using the power rule. So I'm going to put the 3 out in front, so it'll be 3 derivative of x to the fifth. Now you put the 5 in front and then do 5 minus 1 up there. So then that would be 3 times 5x to the fourth, and that'll get you 15x to the fourth. Now I'm going to use the product rule. So what I'm going to do here is get the derivative of x to the third, parentheses 4x cubed plus 2. And so here I'm going to find the derivative of x to the third times 4x to the third plus 2 plus x to the third times the derivative of 4x cubed plus 2. And then next, that will get me 3x squared times 4x cubed plus 2 plus x cubed times 4x times 12x squared. Then you simplify all that, so I'll get you 12x to the fifth plus 6x squared plus 12x to the fifth, and then you'd add the 12x to the fifth together, so I'll give you 24x to the fifth plus 6x squared. That is the answer. Next, I'm going to find the derivative of x to the fifth over 4x to the fourth plus 2 using the quotient rule. So what I'll do here is I'll do low d high minus high d low over low squared. So it'll be low, so it'll be 4x to the fourth plus 2 times the derivative of x to the fifth, and then minus high d low, so it would be x to the fifth times the derivative of 4x to the fourth plus 2, and then all over log squared, so it'll be 4x to the fourth plus 2 squared. So I'm going to simplify all that. So that would be 4x to the fourth plus 2 times 3x squared. Oh, not 3, that's a 5, sorry. 5x to the fourth. And then minus x to the fifth times 2 would cancel out. So that'd be 16x to the third. And so then, all over, I'm going to simplify that. So it would be 16x to the eighth plus 16x to the fourth plus 4 at the bottom. And then I would simplify out the top, and I'm just going to do it all, and that would get me 4x to the eighth plus 10x to the fourth all over 16x to the eighth plus 16x to the fourth plus 4. And there's my answer. Now, I'm going to find the derivative of 2x cubed plus 3 all cubed using the chain rule. So what I'm going to do is, this is my inner function, 2x cubed plus 3, it's my inner, and the 3 is my outer. Then I'm going to find the derivative of the outer function, so I'm going to make 2x plus 3 equal to a, so to make it easier. So the derivative of a cubed would equal 3a squared, which that would equal, I'm going to plug that back in, it'll be 3 parentheses 2x plus 3 and then squared. That's the outer function derivative. Now I'm going to find the inner function derivative, which will be 2x cubed plus 3, which that will equal, the 3 will cancel, that'll equal 6x squared. Now I'm going to simplify this up here, so that will equal, that'll do 6x squared times, and that will equal 4x would be, this way. This will equal 3 times 4x squared. Oh, this is cubed. So that would get me 4x to the sixth plus 12x to the third plus 9. And then I must have put the 3 into there, so it'll be 12x to the sixth plus 36x to the third plus 27. All this times 6x squared. And that, the answer will be 72x to the eighth plus 216 x to the fifth plus 162 x squared. There's my answer. Next, I'm going to find the derivative of 2x to the third minus 3 to the fifth over 5x to the fourth plus 2. And I'm going to use the chain rule and also the quotient rule in this one. So I'm actually going to set up as a quotient rule right now. So it's going to be low d high minus high d low over low squared. So it will be 5x x to the fourth plus 2 times the derivative of 2x to the third minus 3 to the fifth power minus high, so it would be parentheses 2x 3 to the third minus 3 to the fifth derivative times the derivative of low, so be 5x to the fourth plus 2, and all this is over 5x to the fourth plus 2 squared. And so now I'm going to use a chain rule for this right here, the derivative of 2x to the third minus 3 to the fifth. So to do that, I'm going to put 2x to the third minus 3 equal to a, so a equals 2x to the third minus 3. And so then the 5, the derivative of a to the fifth will be 5a to the fourth. And so then that will equal to 5 times 2x to the third minus 3 all to the fourth. So there is the inner derivative, or the outer derivative, sorry. And then the inner derivative will equal 2x to the third minus 3, and that will just equal, that will cancel, that will equal 6x squared. So now I'm going to write out my equation again, so it'll be 5x to the fourth plus 2, and then times 5 times 2x cubed minus 3 to the fourth, and then minus, I'm going to do derivative up here, so 2x third minus 3, and then times, that'll get you, 2 will cancel, so that'll get you 20x to the third, and all this is over, I'm going to simplify the bottom, so all that will be over 25x to the eighth plus 20x to the fourth plus 4. And there's my answer. Now, for our last question, I'm going to need to find the derivative of cosine 4x squared. And so what I'm going to do here is I'm going to use the chain rule for chain trig. So what I'm going to do here is make a equal to 4x squared, and then so the derivative of cosine of a is equal to negative sine of a, and so then I'm going to plug in a, so that will equal negative sine parentheses 4x squared. So there's that, and now I'm going to do the inner function, so the derivative of 4x squared, that will equal 8x, and so now my final answer will be negative sine parentheses 4x squared parentheses times 8x. There's my final answer. Oh, times, yeah, 8x.